The interpolation turning function enables you to perform off-center turning operations on standard machining centers and B-axis lathes in a single setup. In some cases, turning operations are indispensable for achieving quality objectives. For example, to turn the internal profiles of these parts, you would need to set up a very complicated machine setup with a high risk of dynamic imbalance, or else proceed with the complex installation of auxiliary motorized axes. The coupling diameters of the fittings must be machined by turning operations, not milling, to prevent fluid leakage. First of all, you need to perform an orientation so that the tool axis is aligned with the turning profile. With interpolation turning mode enabled, the geometric axes of the workplane begin to interpolate along a circular path. The tool orientation is perfectly synchronized with the angular phase of the circular interpolation. This makes it possible to keep the cutting edge of the tool in constant contact with the workpiece. By moving the offset of the working plane, that is, the axis of the profile to be machined, the diameter interpolated between the X and Y axes is adjusted to obtain the dimensions required for machining. In this way, the machine can carry out the machining, making full use of the potential of turning and profile turning cycles. Let's now analyze the program structure used to machine the part shown in the video. After the usual heading, you need to program a new orientation plane to align the tool axis with the axis of the turning profile. You'll need to choose the best orientation solution based on the machine kinematics and the type of tooling setup. Next, the interpolation turning function is enabled by programming cycle 806. The first toggle lets us choose whether to enable or disable this mode. In the gamma parameter, you set the tool's initial orientation to angularly phase the cutting edge with the part profile. In the XC and YC fields, you must specify the X and Y positions of the axis of revolution, that is, the axis of the profile. It's possible to specify an approach point in the XS parameter, diametral approach, and the ZS parameter, axial approach. The direction of rotation of the cutting motion must be set within the cycle in the DIR parameter. The last parameter contains the tool's revolutions per minute or its constant cutting speed. In the sample part, a profile turning cycle was used, and we'll see its definition later on. For the machining, cycle 952 was used. The definition of this cycle's parameters is exactly the same as for conventional turning. The safety clearances, the feed rates, and whether the operation is roughing, finishing, or both in sequence must be set. If the machining will be longitudinal, as in our case, if it will be radial, or parallel to a profile. The same applies to choosing an internal or external profile. And the same goes for all the parameters of cycle 952, just like in traditional turning. Let's now take a quick look at defining the finished profile to be machined. The generation of the profile, or the profiles needed for machining, is done using the dedicated SINUMERIK editor. It's possible to make full use of this editor's potential by defining chamfers, fillets, and reliefs already integrated in it. For example, Form E, Form F, or DIN. It could be a very useful and flexible strategy for machining relief grooves for bearing seats, etc. Let's create a new program and see where to find the menu for setting interpolation turning and the cycles associated with it. Once the editor is open, press the right arrow to access the second horizontal soft key menu, where you'll find the interpolation turning key. Pressing it displays the vertical soft keys. The second from the bottom is cycle 806 to enable or disable interpolation turning mode, as we've just seen. Starting from the top, we have the classic roughing cycle with its options, as in traditional turning. The same goes for the cycles for creating grooves. You can also use the cycles for grooving operations with angled walls and on conical surfaces. Also, all the cycles for machining relief grooves can be used with the interpolation turning function. This makes it possible to take advantage of all the automatic features provided by the cycle and all the standardized tables integrated into the programming screen. To machine freeform profiles, after defining them in the editor, you then call up the profile name. And you need to choose the machining cycle, selecting between roughing, removing remaining material on the profile, cutting grooves, or removing remaining material for grooves. At the end of the machining process, you need to deactivate interpolation turning mode by selecting Deactivate in cycle 806. In summary, the interpolation turning feature enables turning operations on milling machines or lathes with a B-axis, even for off-center or misaligned profiles. It avoids installing complex add-ons such as powered tools and additional axes. Potentially reduces the number of setups needed by limiting the amount of equipment required. It also allows flexible machining of reliefs, for example for bearing seats, without the need to prepare dedicated tooling. And finally, it allows you to take advantage of the benefits offered by the turning cycles integrated in SINUMERIK. That's all for today. Thank you for watching, and we look forward to seeing you in the next tutorial.